In the last video, I went over examples of common mistakes that are made by mathematics students in their mathematics courses. This video will be a follow-up to that. This will be part 2. I'm going to list the examples that I went over in the last video. Okay, so number 1 we discussed and it was false. Number 2 was true. That was your definition of a base taken to a negative power. Number 3 was false. Number 4 dealt with order of operations, and we discussed this and we said it was false. 5 was just what are your laws of exponents, which was true. Number 6, common mistake, is false. Number 7, just your formula for squaring a binomial, which is true. 8 was true in this case. And number 9, the base is -2. That comes out to true. Okay. 3 factors of -2. Number 10, the base is -2 because you have parentheses. That came out to a -4. Number 11, the base is 2, not a -2, so it's 2 squared is 4. And then the negative makes it a -4, so this one was true. Okay. So let's move on to some more examples in part 2 of the video. So this one says factor completely. We have the difference of 2 squares. So again, I'll let you look at that for a while and then discuss or determine whether you think it's true, whether it's false. That should be enough time. That's false. Okay. Got the difference of 2 squares. So when you have the difference of 2 squares, it's the difference of the square roots and the sum of the square roots. So it should be x minus y, x plus y. The order doesn't matter here. You could have the x plus y first and then the x minus y. So this negative right here makes it false. Okay. Number 13, factor completely again, x cubed minus 8. Look at that, discuss or determine whether it's true or false. Okay, so this one is false. There is a formula for the difference of cubes. So in this case we have x cubed minus y cubed is equal to. So it tells you that the first factor is the difference of the square roots. Or I should say the difference of the cube roots. Okay, so x cubed minus y cubed factors into x minus y, difference of the cube roots, and then the next factor will be the square of the first root here, and then plus the product of the two roots, in this case x and y, plus the square of the second root, that's y in this case. Okay. So in this particular problem then here, if I want to factor, the answer should be, okay, first factor then would be the difference of the cube root. So the cube root of x cubed is x, the cube root of 8 is 2, because 2 to the third is 8, so 8 is a cube. And then the other factor should be the square of the first root. Square of the first one, plus the product of the two roots. So 2 times x is 2x, plus the square of the last root, or the second root. So this would be 2 squared is 4. Okay. So if you were to multiply through here using your distributive property, combine your terms, you should get x cubed minus 8. Okay. So this doesn't factor into this, it factors into this right here. Okay, let's clear this. Okay, so obviously number 14 is true. So I just told you the formula. Okay, so that one is true. X cubed minus y cubed does give you x minus y times x squared plus xy plus y squared. Okay, go to the next one. Okay, factor completely again. Those are the instructions of these problems. Factor, so again, when you factor, of course, obviously you have your formulas. You have difference of cubes, you have difference of squares, you have the common factor method. So in this case, that's really the first thing you look for when you get a factor. Do you have a common factor? So 2x squared plus 7x, the terms are 2x squared and 7x, and they do have a factor in common, the x. So you factor out an x. So is this true or false? False, or could you go further? Well, this is false. Because if you leave it like this, you have to close the parentheses. Now you put a parenthesis here. The 2x plus 7, you can't factor that any further. So this would be the complete factorization, but you can't leave the parentheses out. And that's a mistake that's made very often in mathematics, even in advanced mathematics. You're doing calculations, you're trying to rush, and you leave out a parentheses. So sometimes it might not matter. I mean, if you have 2x plus 7, like that, plus 7 here, plus y. If you leave these parentheses off, that's not going to change that. That's still going to be the same thing because you can't combine these anyway. 2x plus 7 plus y. Okay? But in this case, if you leave out this parentheses, this x is only multiplying the 2x, not the 7. Okay? So, careful with parentheses. 16. We have 2x squared minus 3x plus 2xy minus 3y. So again, when you're working problems involving factoring, your methods are difference of squares, you have difference of cubes, you have common factor method. Okay, you have methods for factoring trinomials. If you have more than 3 terms, then you're looking for a grouping. So in this case, you look at the first 2 terms, 2x squared minus 3x, and you notice that you have a factor in common of x. So okay, so factored out the x, and then 2xy minus 3y. Those terms have a factor of y. So there you have it. So if we leave it like that, would that be correct? Is that true or false? Can I factor this into that? Is that completely factored out? And the answer is no. It's not completely factored out, so this would be false. You have to continue the factorization. So look at the x and the 2x minus 3 and the y and the 2x minus 3 as 2 terms, and they have a factor of 2x minus 3. So take out the 2x minus 3. Just like over here, number 15, the 2 terms had a common factor of x, so we took that out. So in this case, we're factoring out at 2x minus 3. Take out the 2x minus 3, and what are we left with? X plus y. But don't leave your answer like that, because that would be incorrect. You have to put the parentheses here, because then this multiplies the whole thing, not just the x. Okay, if I leave out the parentheses, the 2x minus 3 only multiplies the x, and that's not going to give you the original answer. So the complete factorization for this is 2x minus 3 times x plus y. Clear this. Okay, the next one says simplify. So we have the square root of 9 plus 25, and this is equal to, okay, square root of 9 plus the square root of 25 is equal to, and the square root of 9 is 3, the square root of 25 is 5, 3 and 5 is 8. Is that true or false? This would be false. Okay, this would be false. You can't distribute this radical over addition. Now, if you have something like the square root of x times y, and you can't distribute this over multiplication, you can say that this is the square root of x times the square root of y. Okay. Because in this case, notice, if I were to, since we have numbers here, I can add these up. 9 and 25 is 34. Okay. So I know the square root of 36. I know the square root of 36 is 6. So 34 is smaller than 36, so I should get a number smaller than 6. Okay. And this is saying the answer is 8. So just by that, I know it's false. Okay. So these are just some examples, and of course there's some others. I might consider another video, a more advanced one on common mistakes, but these are just some of the basics that come, or some of the main ones that come to mind based on some of my experiences in my many years of teaching. So we'll go on to something else possibly next time. If you have any suggestions, again, in any videos, any questions, please post them. And if these are making sense to you, and especially if they're helping you a little bit, I'd appreciate it if you subscribe to the channel. And we'll see you in the next video.